Welcome to Transform Now, the podcast brought to you by robotic process automation pioneer Blue Prism. Digital transformation has the potential to reshape the way companies service their customers, engage their employees, and manage their operations. Whether you're looking to develop strategies, tactics, and best practices to positively impact the future of work, or you're curious to learn how other companies have successfully navigated their digital transformation programs, then this podcast is for you. We're here to help you transform now.
Hello, everyone, and welcome to the Transform Now podcast. I'm your host, Michael Marchuk, and today we have a special guest, Dr. Eric Daimler. Eric is an authority on artificial intelligence with over 20 years of experience in the field as an entrepreneur, executive, investor, technologist, and a policy advisor in the United States for the Obama administration. Eric has co-founded 6 technology software companies and has done pioneering work in the fields of software systems and statistical arbitrage. Eric also has a book coming out called The Coming Composability, the roadmap for using technology to solve society's biggest problems. I'm very excited to hear more about that. So glad to have you on the show, Eric.
Good to be here, Michael.
So that's an interesting title for your book. I was hoping maybe you could give us a preview of what you'll be discussing.
Oh, absolutely. The theme of the book is one that has me quite passionate about the implications for society broadly, not to sound too pretentious about it, but it's this idea that there are epochs in human history that can be defined by math, that we have oriented ourselves around the Industrial Revolution based on modularity, intercomposable parts. We oriented ourselves, this is an organizing principle of logic that then enabled a computer revolution. And we're now entering a new epoch, which is around composability. A little like modularity, but it's fundamentally different in that at every point of interchange, think of a train exchanging boxcars, but only extending 2 miles. Think of the train system. At every point of a train system, you can extend infinitely. At every point, and then iteratively or recursively, however you want to say that. So it's a fundamentally different way of thinking about our digital world. And that's what I want to talk about, how it's emerging now, and what the implications are for the future of our careers and the future of our children's education.
That sounds very exciting. I'm really looking forward to reading your book after it's released. Now, in addition to writing your books, you've also written a number of articles on AI adoption, and you mentioned something about business being transformed by AI. Can you elaborate on that a little bit?
Absolutely. More data is being collected every day. And it seems like people have gotten the memo that whatever the metaphor, data is the new oil, is still current. What people often don't realize is that while data growth itself continues to be quadratic, also data source growth, the number of data sources, think Internet of Things, video, what have you, that is also growing quadratically. The difficulty then lies in the relationships between data, and that has just become infeasible, intractable. That's the new difficulty. And how people are working through their AI right now involves a real type of magical thinking. So if you think of the metaphor of a needle in a haystack, people have thought that, if I just add more hay, I can find that needle. Or the other one that comics have been written about, which is for data scientists, hey, just stir that pitchfork in the hay some more, and eventually you'll come out with some conclusions that we like. That's often what data scientists find themselves doing, just manipulating these statistics, manipulating more and more data, when really what should happen is that we should take a bucket of hay and just try a heuristic, and then maybe later a more formal algorithm about how we might search within a subset for the needle. The business application would be taking a small section of your data and working with RPA or some sort of automation algorithm to begin to automate that sequence. But these data relationships are expanding beyond the ability of even the smartest companies to address. We worked with a ride-sharing company everybody's heard about it, that grew up like all companies grow up. They grew up focusing on their business. They didn't grow up focusing on having the optimal IT infrastructure. They grew up, in their particular case, city by city or jurisdiction by jurisdiction. That resulted in this hodgepodge of IT data IT infrastructure represented by these multiple databases and multiple different vendors, they had 300,000 of these databases. And that is just insolvable with traditional systems. It's an intractable problem, or infeasible, I guess you might say, because a lot of the existing tools could integrate one or two or maybe five databases, but it can take months, if not years, and involve 7, 8, maybe even 9-figure US dollar budgets. Uber, having some very smart people and an effectively infinite balance sheet, still couldn't solve that problem. They looked to a more foundational level of math as a solution to that problem. They found categorical algebra. Then they found the leaders and the software expression of that, and they found us. They have Stanford in their backyard, but they found us. We happen to be 40 miles north of them, which is fortunate. But that's where I think AI adoption is being throttled, and where automation like RPA is going to be refreshed in the possibilities for businesses, and the new power for this math in integrating large parts of the data that the businesses are already collecting.
So do you see AI being applied in every business?
Yeah, I think the idea is that data relationships will drive the future. That's the point about every business really being an AI business. That Delta Airlines, for example, they collect data on me, my height, my age, me based in San Francisco. But those are pieces of data that become commodities. Data is all around us. But the data relationships, how frequently I fly from San Francisco, where do I go? That is the data relationships. It's the relationships between the different characteristics of the data that Delta Airlines collects about me that determine some things that are then proprietary to Delta, such as how often are they going to upgrade my class of service? These are important to me, and they're important to Delta. That sort of data relation is what's going to drive business in the future. How much do they understand about their customers and the dynamics of the market? Those data relationships are what people are going to want to spend their energies collecting, maintaining, and curating.
So because each industry or each organization has their own data relationships, how does that factor in when considering how best to apply specific technologies? Because there could be so many different types or sources of data, or does it matter?
Yeah, it doesn't really matter where the data comes from. There's many types of dirty data, I guess you can say. This may get into the idea of biases or distortions of data. When I was in the federal government, the biggest source of data may be surprising in some ways, unsurprising in others. It's NASA. They scan the universe quite literally for collections of data, but we couldn't really do anything with that for any experiments in data science, or many experiments, because it had a lot of dirty data that we didn't really know how to process. That's a type of dirty data. And there's a lot of good companies trying to solve that problem or other organizations and other use cases. And there's many types of bias as well that might be present in different collections of data. We know ones that may be distorted by the past. They could be distorted by race or ethnicity or gender or what have you. They can also be distorted by the presence of data or by the absence of data. We worked with a hospital chain that had different definitions within the same group of diabetes, right? One group, for their own reasons, defined diabetes as a yes, no. And another group defined diabetes for their own uses as, oh, how are we treating it? Those are all, contextual expressions of data, all inside one hospital system in this particular case. And that can represent its own type of bias. My firm was also working with a company trying to do ESG reporting, the environmental social good reporting. That itself we found to have bias because we could easily collect data for this within the developed world, but we found that we didn't have that data for the developing world. And that presented its own distortions, and correcting that has its own complications. So those are the ways in which the collection of the data, the curation of the data can express many different types of bias or distortions of reality around which organizations need to be mindful.
So that makes complete sense. And we've talked a lot about data. As you look towards the future of automation, we see ever increasing potential that comes with combining traditional RPA with the power of AI to create more of an intelligent automation. Where do you see the next wave of this business automation? Is this industry specific? Are there general themes that are emerging across industries? How would you describe it?
My understanding of the limitations of our RPA and automation in general has often been around the difficulty of retrofits from the legacy technologies. I think that limitation is coming off. One piece of news I was talking to a friend about today was the rethink of helicopters and their evolution into quadcopters. We might call that an evolution. What has enabled that revolution isn't in the mechanics. It's actually in math. And that mathematics is what has enabled this otherwise infeasibly complicated 8-rotor system to become airborne in a safe way. And it's now that we have a model to relate to these sort of difficult interactions. So in robotic process automation, that will manifest itself with different data sources and different models now being able to connect in a different way. The example is when we think about cooking, we know that we need to adjust our cooking time based on altitude. And we can do that in a rather predictable, that there's a lower boiling point at higher altitude. So you often have to cook things for longer in whatever way you're cooking. That sort of formal relationship is now going to be able to be captured through this mathematics of category theory. That is the type of thing that allows for these legacy systems to then interact with more modern data infrastructures. That's a kind of the common composability that I talk about in my book. And this is represented in a lot of different places in our world, that from quantum computing, where the compilers would not be able to be interpreted without category theory or type theory, to smart contracts that also wouldn't be able to exist without category theory or type theory. There was an issue in the European Union where they introduced regulation for their GDPR modifications to their regulation, where they wanted a pseudonymization provably applied to their citizens' data. That can't be provably affected without category theory, without this deterministic AI enabled by category theory. That's where I'm seeing this interaction playing out with RPA over the next 5 to 10 years.
That makes sense. That makes sense. As automation and these new theories leveraging math become more complex and their interrelationships become more distorted or conform to whatever the next thing is, can businesses rely on this brand new technology or brand new thought processes when they've been doing business in a particular way for decades, perhaps centuries? Are there any caveats that you might apply to businesses who are truly transforming from one business model to a newer business model that they can rely on?
It's really important to remind ourselves that as scale increases, complexity increases. It's really a fundamental dynamic. If people will be fooling themselves to think that somehow the world is getting simpler. Now, we will find ways to simplify parts of our world. We've done that over hundreds of years, not thousands of years. As complexity increases, we simplify parts of that system. In this particular time in which we live, we can see that context may be the place where we can first address this issue. And so the context can matter. If I'm a company with low stakes expressions of my automation, such as digital advertising, I don't really care so much about my failure rate within a rather large window. I can just throw up another ad. But in other contexts where life and limb are at stake, say commercial jet aircraft, that matters. We can't tolerate really any sort of error in that. When we want to translate the concept of vibration between the different data structures in one organization, the integrity of the semantics of vibration need to be guaranteed as they are transferred within that organization. So the context matters when I'm applying automation. AI in general might best be thought of as having these two branches of deterministic and probabilistic artificial intelligence. It's certainly all the sexy press has been most recently biased towards the subset of probabilistic AI called ML and the subset of ML called deep learning. And there's some fantastic innovation going down there. But I am not of the school that thinks there is some religious argument to make about the entire world being in deep learning or in probabilistic AI. There are some people are in that group. I am of the group that there will be expressions in a combination of probabilistic and deterministic AI that apply to appropriately different sets of problems. For example, we worked with a research group that wanted to share data among a broader team, but they couldn't afford to have their data be misinterpreted. So they collected all this important data, and in one case it was chemicals. And you can just imagine if you have a chemical H2O, water, and you don't want that to be misinterpreted as O2H, that would just merely transposed poorly in another application. Bad things can happen in chemistry. Explosions can happen. You want that data to be properly interpreted. And these are in high context environments. Conexus is doing the same thing about electronic health records, where you just cannot afford to be misinterpreting Jeff or Jeffrey as either being the same person or different people. You have to get that 100% right to avoid leaking data or merging the wrong person's data inappropriately, and therefore with their drug sequence or any sort of medical history. Back to Conexus's application in commercial aerospace, the issue of vibration between different database systems can be a really complex one, especially if one database is in SAP, another one is in Oracle. Translating those between different contexts, different departments that have really different needs to be provably complete. And that's really only available in the mathematics of category theory. That's really the future. And that's how companies are going to be able to rely on their automation systems, on their AI in the future.
That's a great way of putting it. So I have a question regarding context, especially when you look at it from the two ends of the spectrum you mentioned. We had the advertising example, which the data doesn't really matter as much, but we have the lives of hundreds of people in the other example, in an airplane, for example. Those are pretty big extremes. If I look towards the middle, where we say have traditional day-to-day corporate transaction processing, when does a company know whether its context is good enough? What can be or should not be applied in a data set?
I think the issue there is to determine how big of an error you can afford and whether you really understand the downstream implications of those errors. We as humans are pretty bad at math intuitively. We're often bad at fractions. What is 2/3 of 3/4? That often gets people running to a calculator or laying something out on a sheet of paper. They can't immediately say, oh, 1/2. That sort of thinking about fractions and error rates can often put people in a spin. Probabilities are the same way. If you tell people that you have an automated car that is 95% safe, plus or minus 5%. People may say, well, that's a killer robot, not knowing that maybe the number I gave them was actually their own safety record. So people just don't know how to think about probabilities and much. There are some things that need to be provably complete and some things that don't. In the case of Uber, what they found is they wanted to answer some simple business questions, such as we just passed the Super Bowl and they wanted to know before then, how do I predict driver supply or rider demand in Chicago versus Milwaukee? they needed to do that separately for the cities. They would need to do Milwaukee and Madison and Chicago all separately and then do a statistical comparison. They couldn't do the whole of Illinois and Wisconsin, let alone the region or the world. And that produced some sort of friction, both in its accuracy and in its timing. So they determined that they needed a very high level of accuracy. It's not life and death, but it impacted their business results. And to have them tell it, Conexus' work with them produces low 8-figure annual savings with the better business intelligence they get out of a more closely integrated data set.
That makes sense going through that, because knowing the business model and knowing where you'd like your outcome to be helps you to be more contextually specific. The challenge is, do we have enough people when we get to that gray area to know that impact? Because I would imagine within Uber, there's quite a few data scientists working in that organization to be able to help guide and support some of that context decision discussion. But perhaps in a bank or a large manufacturer or retail firm, they'll have some resources allocated to that, but they may not have the same volume of resources or have those resources allocated to the decision processes made to help contextualize some of these things. Is there a way that organizations can bucket them into reasonable chunks that would be good enough? Or is this something that has to be much more specific?
I think what you're getting at is the future, which is encoding implicit knowledge. So a lot of what is done in some of these large companies is work from our heads. We just have learned over time what is required inside of the machines that we help to operate. The future is going to be making the implicit explicit. And once we put our subject matter expertise, our implicit knowledge down in a way that is encoded in the larger process, it becomes more clear how we can integrate that explicit knowledge with other explicit knowledge, capture it, encode it, encapsulate it, and then redeploy it in different contexts. What we find right now is that humans introduce a lot of errors in work. So as you think about these sort of gray areas, these can be places in an organization where the errors compound and it slows the entire process. We work with one financial firm that we found that they got the memo on collecting data, and they have a lot of data set in these different silos across the organization, but bringing that data to bear on a business decision is often to be infeasible. They have to go to their data scientists would have to go to their boss and ask for some resource allocation from data engineering, looking for a budget of time and money, often in the 7 figures, to integrate a silo from another department. When really, they don't want it to next year, they want it next week. That sort of thing is super difficult. In resource-constrained environments, the motivation to do some of that work, bringing the implicit to be explicit, is actually going to be stronger because they don't have the sort of Ferrari mechanics of data science that enjoy the internal prestige of fixing these intractable problems. They need to automate the systems they have. They need to encapsulate their knowledge that's held in their people's brains and put it in code.
That brings me to my last question, and that relates to this human component as we're talking about organizations. Certainly at this time where we're looking at the Great Resignation, where there's a lot of transfer of knowledge that is leaving your organization and new knowledge and new experiences coming into the organization, which could be both good and bad as we look at it from that transfer. How do you see organizations being able to leverage AI to be able to support or cushion the blow of this transfer of knowledge in and out?
I was just talking to an economist friend of mine who was actually reminding me that this great resignation or great migration actually may be a little bit of a myth because we are talking about it in the large, but really it is most often felt right now outside the knowledge industries. It's in the retail sector, in logistics. So I haven't seen it among many of our clients to the extent that we read about it in the press, but we certainly have that. Some people certainly see that as a concern over time. It really expresses itself in the same way that there is a concern about legacy technologies and integrating legacy technologies. We eventually retire old systems. We worked with another manufacturer who had an old system built on mainframes with COBOL. I didn't even think this existed. I thought this was old 30 years ago, but it's still around. And they had to, still having to invest tens of millions, if not hundreds of millions of dollars, bringing up new systems because they can't provably migrate these old systems to new systems in a way that's dependable. They have to write this sort of thing from scratch. That they're trying to now avoid by encoding this implicit knowledge. So this gets to this repeated point about where the future is going to be captured. We don't want to spend all this time as an organization learning about the dynamics of airflow over a foil, encode that in a system that 10 years from now or 2 years from now, if somebody leaves, we have to recreate on a new system with new people. This is hard-won data. It's data that we've spent a lot of money collecting about our customers or about the market dynamics. We need to make sure that is encoded as knowledge, as data relationships. That's how I see the future opportunities in AI, is capturing these data relationships in an encoded, encapsulated way that then can be redeployed around the organization in different contexts.
This is fabulous. This has been a very interesting conversation. I really appreciate you joining us today. A lot of good topics, a lot of great examples that were very easy to follow for folks like me who sometimes need a calculator nearby when they get asked math questions. So thanks again for the explanations you provided and the way you approached this topic. It was very helpful, and I want to thank you for sharing it with us.
Thanks, Michael. This was fun.
Thanks for tuning in to Transform Now. For more insightful discussions on digital transformation and more, check out our podcast channel where you'll find all of our previous episodes. To make sure you never miss an episode, subscribe to the show on your favorite podcast player. And if you like what you heard, please leave us a review. For more information about digital transformation and the future of work, check out blueprism.com to learn how Blue Prism's digital workforce is enabling enterprise transformation now.